All right, the reason you're probably watching this video is because you're either having trouble finding the lines of symmetry equations or you're having trouble being confident finding the equation for the asymptotes. Before I begin here, we need to figure out what's going on in this equation. We have a 5 that's a stretch factor, you have x minus 4, and if you have x minus 4 that's being grouped like this and a minus 8 at the end, that you probably already figured this out, that your center locator point is going to be at 4, negative 8. Then, as you go over to your graph and graph this out and put a dot at 4, negative 8 like this, then you have to also know that there are two asymptote equations. These are dotted lines the graph gets close to in this case and does not touch. So if I were to graph the vertical asymptote, it would look like this, and if I were to graph the horizontal asymptote, it would look like this. Now, asymptote equations, something to talk about that first. If you ever have a horizontal asymptote, what axis does it hit? Well, it hits the y-axis. So if it was hitting the y-axis, let's say just 7, then you'd say the equation for this asymptote, or this horizontal line, is y equals positive 7. And you always aren't, so if you're never confident what letter it is that goes with the number, if it's hitting the y-axis, you say y equals. And if it's hitting the x-axis, you say x equals. So in other words, then if I had a vertical line that I want to see the equation for, if it crosses the x-axis at, let's say, 3, then you'd say the equation for this one is, what axis is it hitting? It's hitting the x-axis, so you say x equals 3. And that's how you write the equations for vertical and horizontal lines. Now in this picture right here, you're noticing that it's a vertical line hitting the x-axis at 4. So that equation answer will be x equals 4. Then the other one is a horizontal asymptote here hitting the y-axis at negative 8. In that case then, I'll say y equals negative 8. That's how you find the asymptote equations. Now, if you're going to try to graph this problem, you then would try to graph the locator point, or use the stretch factor to help us find a point that's actually on the graph. So if I were to go to this one right here, and if I were to go 1 unit to the right and 1 unit up, and then 5 units up because the stretch factor is 5, you would then have a locator, or a point on the graph that's right here at 5, negative 3. Let me just put that one on here too, at 5, negative 3. So then, once you've got that point established, then you draw the actual graph through that point. Also understanding that you're also going to do that same thing as you go to the left. You'll go 1 to the left, and if you go down 5, since hyperbolas are symmetrical, you'd have this dot here to go through as well. And then it would swoop down and swoop up. Now that we have the graph, we can talk about lines of symmetry. Now, lines of symmetry are a place you could put a mirror and get the same thing on both sides. As you can see right here, I've got a line that's drawn in here, and then with a slope of 1, and it hits the y-axis at negative 12. So with graph paper, it's pretty easy to see that the equation answer for this problem would be y equals a positive slope of 1, x, and then minus 12. And that's one of my answers. You're also going to know that we have another answer here. I could put a mirror going the other direction. Let's say I put a mirror going this way instead, like this green line. I would still have the same thing on both sides. And that answer would also be then y equals a negative slope of 1, or negative x, and that crosses the y-axis for a y-intercept of negative 4. And you'd write the answer like this. So those are the two lines of symmetry equations. And yeah, it's really easy to find when you actually have the graph to look at and put the actual dots on the paper. However, if all you had was just this equation to look at and find the answer, we need to have a formula that will help us figure this out. So the formula that you're going to use to find this out, and if you looked at this, how can these two numbers be used to find that y-intercept of negative 12? Well, the way you find that is by going the k value minus the h value. If I take k negative 8 minus 4, you get negative 12. So this one right here for the positive slope equation, I would take k minus h, and I would then have this actual number. So here's the formula. If you're taking notes, this is what I would remember for future problems that you have that have different locator points. You'll do this. Y equals your positive slope equation will then be plus this answer right here, k minus h. Okay? And then the other equation that has a negative slope, this one down here, the green one, to get an answer of negative 4, you simply just add these two numbers together. Take k plus h. And that's how you find the other line of symmetry. So the one that has a negative slope, you add the k and the h, and then when the one that has a positive slope, like the first one there I had, you subtract the k and the h. But I'll finish this problem right here. I'll do negative x plus, and in this case it'll be k plus h. That's the formulas you want to use for trying to find the lines of symmetry of no matter where the hyperbola ends up for locator point. Use these two formulas to find the two equations, and that's all you need. Hopefully this video helps in getting those two answers to your problem fixed, and good luck.